Welcome to Earthquake Tip number 13. My name is Shailesh Kumar Agarwal, Executive Director of BMTPC, and I'm going to present to you all about earthquakes, its concepts, terminologies, and how to construct buildings and structures to withstand earthquake forces through 32 earthquake tips, which are authored by Professor C.V.R. Murthy, mentored by Professor Sudhir Kumar Jain, and developed by IIT Kanpur in association with Building Materials and Technology Promotion Council, that is BMTPC. Through these tips, our aim is to spread the right technical information in simple to understand language to our professionals who are in the field designing and constructing structures, especially our architects and engineers. But before we start, let's make a pledge that any new structure we design or build must be earthquake resistant. This earthquake tip number 13 will explain why should masonry buildings have simple structural configuration. Remember, in the previous tip, it was deliberated that to improve seismic behavior of masonry buildings, the integral box action is to be ensured to transfer large horizontal forces between roof, walls, and foundation without major damage or collapse. In this regard, appropriate choice of structural configuration can also help, and that will be discussed now. The structural configuration of masonry building means overall size and shape of building, distribution of mass, and horizontal or lateral load resistant elements across the building. Large, tall, long, and unsymmetrical buildings perform poorly during earthquakes. It was explained to you in the previous tip as well. Loosely connected roof or unduly slender walls are also threat to good seismic behavior. A good box action between all the elements of building, that is, between roofs, walls, and foundation, ensures earthquake-resistant construction, as shown in this figure. For example, a horizontal band introduced at the lintel level ties the wall together and helps to make them behave as a single unit, like box. So it's called box-like action. Openings are also functional necessities in the buildings. However, their location and size assume significance in deciding the performance of masonry buildings in earthquakes. Let's understand this through this figure. During earthquake shaking, earthquake forces act in strong direction of some walls and in weak direction of others. Walls shaken in the weak direction seek support from the outer walls as shown in this figure. Walls B1 and B2 seek support from walls A1 and A2. Let me explain this further. Wall B1 pulls wall A1 and A2, while wall B2 pushes against them. At the next instance, the direction of shaking could change to horizontal direction perpendicular to that shown in this figure. That means wall A and B will interchange their roles, means B1 and B2 will become strong ones and A1 and A2 will become weak ones. Thus, walls transfer loads to each other at their junctions, besides lintel band and roof. Therefore, the masonry courses from the walls meeting at corners must have good interlocking. This is the reason that openings near the wall corners are detrimental to good seismic performance. As you can see in this figure, openings too close to wall corners hamper the flow of forces from one wall to another. Further, large openings weaken walls from carrying the inertia forces in their own plane, and thus it is best to keep openings as small as possible and as far away from the corners as possible. Indian standards suggest a number of earthquake-resistant measures to develop good box action in masonry buildings and improve their seismic performance. For instance, it is suggested that a building having horizontal projections when seen from the top, that is, like a building with plane shapes like L, T, Y, E, must be separated into simple rectangular blocks in plan, each of which has simple and good earthquake behavior. This was also explained to you in one of the tip earlier as well. During earthquake, these separate blocks can oscillate independently and even hammer each other if they are too close. Thus, adequate gap is necessary between these different blocks of the building. The Indian standard suggests minimum seismic separation between blocks of buildings. Now let's talk about staircases. Inclined staircase slabs, as shown in this figure, in masonry buildings offer another concern. Uh, an integrally connected staircase slab acts like a cross brace between floors and transfers large horizontal forces at the roof and at the lower levels. These are areas of potential damage in masonry buildings if not accounted for in staircase design construction. So, what should we do? As you can see in this figure 4b, staircases are completely separated and built on a separate reinforced concrete structure. Also, adequate gap is provided between the staircase tower and masonry building so that they do not hammer each other during earthquake shaking. This is all about earthquake tip number 13. You can download this earthquake tip from www.bmtpc.org. The next earthquake tip, that is tip number 14, will be on why are horizontal bands necessary in masonry buildings. Thank you.